everyone, welcome back to my channel. Today I'm going to talk about application-oriented topic on modular arithmetic, that is RSA algorithm. To understand the concept of RSA algorithm, we must know about cryptography. Cryptography is a process of hiding or coding information so that only the person a message was intended for can read it. Here, cryptography is a method or process of hiding or coding the information so that only the person a message was intended for can read it. So that's about cryptography. Key concept of cryptography includes encryption and decryption. Here, the concept involved in cryptography is encrypting the message and decrypting the message. Two different kinds of cryptography systems are private or secret key cryptography. Another one is public key cryptography. Here, two types of cryptographies are private key cryptography, or it is called as secret key cryptography. Another one is public key cryptography. Here, in private key, sender and receiver agree on secret key that both use to decrypt the messages. But in case of public key, it is used to encrypt the message. With the help of public key, we can encrypt the message, and private key is used to decrypt the message. Here, in private key, both sender and receiver agree on a secret key. That means both sender and receiver know the secret key and they both use to encrypt and decrypt the messages. But in case of public key, it is used to only encrypt the message. In public key is used to only encrypt the message and private key is used to decrypt the message. So this is about private key cryptography and public key cryptography. Modern system use public key cryptography. Best known public key algorithm is RSA algorithm. Here modern system use public key cryptography rather than private key cryptography. Here best known public key algorithm is RSA algorithm. So this is RSA algorithm. Now let us understand what is RSA algorithm. Here the name RSA algorithm, here the name RSA stands for Ron Rivers, Adi Shamir and Leonardo Adleman algorithm. Here RSA is a name of a scientist who developed the algorithm called RSA algorithm. Here RSA means Ron Rivers, Adi Shamir and Leonardo Adleman algorithm. So RSA algorithm is an asymmetric cryptographic algorithm which is used to securely transfer the message with the help of internet. It is based on a principle of number theory, specifically on the difficulty of factoring large composite numbers into their prime factors. Here, RSA algorithm is an asymmetric cryptographic algorithm which is used to securely transfer the message with the help of internet. Here, main intention of RSA algorithm is to transfer the message. So it is based on the principle of number theory, specifically on the difficulty of it is used in the case where large composite numbers are factorized into prime factors. With the help of this RSA algorithm, we can easily factorize large composite numbers into their prime factors. So this is a main principle of RSA algorithm. So now the RSA algorithm is a block of cipher in which the plain text and the cipher text are integers between 0 to n-1 for some value of n. Here the cipher text is nothing but cipher is an algorithm for encrypting and decrypting the data. Here cipher is nothing but a secret code. Here RSA algorithm is a block of cipher in which the plain text and the cipher text are in the integers between 0 to n-1 for some value of n. Here RSA algorithm converts the plain text into a cipher text. Here cipher is nothing but an algorithm for encrypting and decrypting the data. Cipher is nothing but it is an algorithm which is used for encrypting and decrypting the data. It is a secret code. So this is about definition of RSA algorithm. Next we shall see how to find RSA algorithm. Here to find RSA algorithm, first step we have to generate the key. That is a first step. Here key generation is a first step to find RSA algorithm. Here to obtain the key generation, first you have to select two large prime numbers, that is mentioned as small letter p and q. Next calculate n is equal to p into q. Next after calculating n is equal to p into q, next you have to calculate Euler's torsion function with the help of a formula, that is phi of n is equal to p minus 1 into q minus 1. We already discussed in a previous videos how to find the Euler's torsion function. Here In the RSA algorithm, we can find Euler's torsion function with the help of phi of n is equal to p minus 1 into q minus 1, where p and q are prime numbers. Next, once we obtain phi of n, choose the value of e such that 1 less than e less than phi of n and the GCD of phi of n comma e is equal to 1. Here, after obtaining phi of n, next we have to calculate the value of e with the help of that e must be lies between 1 and phi of n. Here 1 is less than e and less than phi of n, and that GCD value of phi of n, that is Euler's torsion function, and the value e must be equal to 1, that is both are relatively prime. So we have to choose the value of e with the help of these two conditions. After obtaining e, we have to calculate d is congruent to e power minus 1 under modulo phi of n, or if you can take e power minus 1 to the left hand side, we get d into e is congruent to 1 under modulo phi of n. You can multiply throughout this congruency by e, we get e into d is congruent to, here e into e power minus 1 is nothing but 1 by e gets cancelled, remaining is 1 under modulo phi of n. So this is to calculate ed is congruent to 1 under modulo phi of n. Next, we have to find the public key with the help of a formula. Here public key is given by the formula flower bracket of e comma n. Here this is a formula to find public key. Similarly, the private key is find out with the help of a formula flower bracket of d comma n. Here to find public key and private key, first you have to find e value. Here e value is chosen with the help of a condition 1 less than e less than phi of n and the GCD of phi of n comma e is equal to 1. Similarly, with the help of e, you have to find the private key with the help of a formula e into d is congruent to 1 under modulo phi of n. Here private key is flower bracket of d comma n. So this is how to find public key and private key. So this is about key generation. Here with the help of two prime numbers, first you have to find n is as p into q. Next, with the help of p and q, we have to find Euler's torsion function, that is phi of n, which is equal to p minus 1 into q minus 1. After finding Euler's torsion function, we have to choose the value e such that 1 less than e less than phi of n and the GCD of phi of n and e must be relatively prime. After obtaining e value, next we have to calculate d with the help of a congruency formula. E into d is congruent to 1 under modulo phi of n. So with the help of all these values, the public key is generated as e comma n and private key is generated as d comma n. So this is about key generation. That's the first step. Next step is encryption. How to find the encryption? Here the formula is given by capital C, which is equal to m power e under modulo n. So this is a formula you have to remember to encrypt the data. Next, after encryption, we have to find the decryption value. Here decryption is nothing but m is equal to c power d under modulo n. Here the value c and m is nothing but, here capital M is nothing but a plain text. Here capital M is nothing but a plain text which must be less than n value. Here you have to note that the plain text m must be less than n value and the capital C is nothing but a CPL text. So this is about m and c. Here encryption is nothing but c is equal to m power e under modulo n. Decryption is capital M is equal to c power d under modulo n. So this is about encryption and decryption. So this is steps to find the RSA algorithm. We shall see some of the important problems on RSA algorithm. Here is the first problem. Encode stop using RSA algorithm with a key 13,2537 and P is equal to 43, Q is equal to 59. Here we have to encode the message STOP using RSA algorithm with the key 13,2537 and P value is 43, Q value is 59. First take the given data. Here they have given P value is 43 and Q value is 59. Also they have given public key is given by here 13,2537. Therefore E value is 13 here because here the public key is given by the formula E comma N, where here E is 13 and N value is 2537. We can check this N value. Here this key given is a public key because public key is nothing but the value which made known to everyone. So it does not be a private key. So this is a public key. So public key is given by the formula E comma N. Here by given data E value is 13. Next take N value. Here N is equal to P into Q. Here we know that N value is P into Q. Multiply P and Q. Here P is 43, Q is 59. Therefore we get 2537. That value is our N. We can directly write n value as 2537 because with the help of formula public key is e comma n. Here e is 13, n value is 2537. Next, after obtaining n, next we have to find the Euler's torsion function with the help of formula phi of n is equal to p minus 1 into q minus 1. Here p minus 1 is 43 minus 1 is 42, q minus 1 is 59 minus 1 is 58. If we multiply these two value, we get 2436. That is our phi of n. After obtaining phi of n, next already they have given e value is 13, so we have to check the condition holds or not. Here that e must be lies between 1 and phi of n. Obviously 13 lies between 1 and 2436, and also we have to check the condition. The GCD of phi of n comma e is 1 or not. Obviously the GCD of 2436 and 13 is 1 because 13 is a prime number. The only divisor of 13 is 1 and 13. Obviously the greatest common divisor among these two is 1. So both the conditions satisfied, therefore given e is equal to 13 also satisfied. After obtaining e value, next here we have to encode the message STOP. So the message to be encrypted, firstly we have to convert that encrypted message to a numerical form. So the following method is used to encode the message. Here the following method is used to encode the given message. Here the alphabets from A to Z, we can write numbers from 0 to 25. Here we have to assign the values or numbers from A to Z as A as 0, B as 1, C as 2, D as 3, E as 4 and so on, X as 23, Y as 24 and Z as 25. So this is a numerical form we have to use to encrypt the message. So with the help of this, STOP is encrypted as, here the secret message to be encoded is STOP. Then here STOP is nothing but a M. M is nothing but a plain text they have given or mentioned already, that is our M value. M value is STOP. So with the help of a table we can assign STOP as, here S is 18, T is 19, O as 14 and P as 15. So this is our M. We have encoded the given message STOP with a numerical form as 18, 19, 14 and 15. Next step, we have to find the C1 and C2 value. Here they have given M as STOP. So to find this C value it is difficult to find for this larger value. So to obtain or reduce to a smaller value, we can take this as, here we can take this 1819 as M1 and 1415 as M2. Next, this is our M1 and this is our M2. Using this M1 and M2, we have to find C1 and C2. If we multiply C1 and C2, we get a value of C, that is CPR text. That's a procedure to be followed. So we know that C is equal to capital M power E under modulo N. Here M is nothing but a plain text, C is nothing but a CPR text, that is encryption is given by the formula capital C is equal to capital M power E under modulo N. So to obtain the C value, first you have to find C1 and C2. Therefore C1 is given by the formula M1 power E under modulo N. C2 is given by the formula M2 power E under modulo N. Here C1 is for M1, that is 1819, C2 is for M2 1415. Call this as equation number 1. So first we have to find C1 for M1 and next we have to find C2 for M2. So C1 is equal to, here M1 is 1819 to the power of E is 13 under modulo N is nothing but 2537. We already find out the value of N as 2537. So first we have to find C1 value. So call this as equation number 2. Here we have to find the remainder value for 1819 to the power of 13 under modulo 2537. Here we already discussed in the previous videos to find the highest value or to find the remainder for a highest value if we divide the value by the given n value. But I use here a different method, that is a calculator method, to find the remainder for a greater value. It is a very easy procedure. So we have to find the value for 1819 to the power of 13. That is, we have to find the remainder value when 1819 to the power of 13 is divided by 2537. So for that, First take, we know that 1819 to the power of 2, that is 1819 square is congruent to 513 under modulo 2537. This means 513 is a remainder when 1819 square is divided by 2537. I will show how to use or how to find the remainder for this value with the help of calculator method. In previous videos, we studied how to find the remainder for a greater value with another type of methods, but here we are using calculator method. Here this is a very easy method to find the remainder for a greater value. Here first we have to take the value, that is 1819 square. In the calculator we know that 1819 square is 3308761. Next step, we have to divide this 1819 square by n value. Here n is 2537. If we divide this value, we get a value as 1304.20221. Next step, we have to subtract this value with the value which is up to the point, that is 1304.20221. We have to subtract this value by 1304. Up to the point value we have to subtract, we get a value as 0.20221. Next step, we have to multiply this value by n. Here 0.20221 into 2537, we get a value as 513. Therefore, we can conclude that 513 is a remainder when 1819 square is divided by 2537. So this is a very easy method to find the remainder with the help of calculator method. Here calculator method means first we have to take the value which is divided by the value 2537. Here we have to divide 1819 square by 2537. That means we have to find with the help of calculator the value 1819 square. That value is 3308761. Next we have to divide this value by n, that is 2537. We get as 1304.20221. So we have to subtract this value by the value up to the point. Here 1304, we get a value as 0.20221. But to multiply this value by 2537, we get a remainder value, that is 513. Therefore, we can conclude that 513 is a remainder when 1819 square is divided by 2537. This is very easy method to find the remainder. Here you can ask me, we can use instead of 1819 square, we can directly use 1819 power 13, but it is difficult to find the value of 1819 power 13 with the help of calculator. We get a exponential values. That is a wrong procedure. So we have to apply this by step process. Here calculator method is used only for a normal values. So we are taking 1819 square, which is congruent to, here we get a remainder value as 513 with the help of calculator method. Next, for this value we can raise the power of 3 on both the side. 1819 to the power of 2 into 3 is 6. So that's the next step. Raising the power 3 on both the side, we get 1819 square whole power 3, which is congruent to, here right hand side also 513 cube under modulo 2537. So in the left hand side we get 1819 to the power of 2 into 3 is 6, which is congruent to, here also we have to find the value for 513 cube. Here 513 cube with the help of calculator we get a value as 13505697. So we get a larger value. So to obtain a smaller value we have to find the remainder value for this. So we have to find the remainder value with the help of calculator method again. So using calculator method we get 513 cube as 13505697. Using same procedure as before, here 513 cube value is this. Next step, we have to divide this value by n value. Here n is 2537. If we divide 513 cube by 2537, we get a value as 53214.7012. Next step, we have to subtract this value with the help of this starting digits up to point value, that is 53214. That is the next step. So we get a value as 0.7012. Next, after obtaining this value, we have to multiply multiply this value with n value. Here n is 2537. So we get a value as 1778.9444. You can check with the help of calculator. We get a value as 1778.9444. We can approximately write this value as 1779. Here we get this value as 1778.9. So 0.944 we can write this as, we can add that value. So we get to 1779. We get a value as this. So in the right hand side 513 cube, we can write this as 1779 because here 1779 is a remainder when 513 cube is divided by 2537. So in the place of this we can write this as 1779. So this value is nothing but 1819 power 6 is congruent to 1779 under modulo 2537. This means 1779 is a remainder when 1819 power 6 is divided by 2537. Both are same. Next, here in the left hand side we have to obtain 1819 power 13. For that, in the next step, again we have to raise the power 2 on both the side. Here if we raise the power 2 on both the side, we get 6 into 2 as 12, which is nearly equal to 13. So to achieve that value, we have to raise the power 2 on both the side. We get 1819 power 6 into 2 is congruent to, here right side also, 1779 power 2 under modulo 2537. Next step, in the right hand side, here we have to find the remainder value for 1779 power 2. That's the next step. Here again we have to use calculator method to find 1779 square. For that, first you have to find 1779 square as, here we get a value as 3164841. So in next step we have to divide that value by 2537. That's the next step. Here we divide this value by 2537, we get a value as 1247.47379. Next step, we have to subtract this value by 1247. We get value as 0.47379. So we get the value as 0.47379. Next step, we have to multiply this value by 2537. That is a n value. So if you multiply these two value, we get a value as 1202.00523. So we can neglect that value. We get a approximate value as 1200. Therefore, we can conclude that 1202 is a remainder when 1779 square is divided by 2537. So in the place of 1779 square, we can write this as 1202. Next, in the left hand side, we get a value as 1819 power 12. But in the left hand side, we must get 1819 power 13. For that, next step, we have to multiply throughout this congruency by 1819. We get, here if you multiply these two value, here bases are same. If we add the power, we get 12 plus 1 is 13. So in the next step, we get in the left hand side 1819 power 13 is congruent to, here we have to multiply 1202 by 1819. We get a value as 2186438 under modulo 2537. Next step is also same. Here we have to find the value for this. Here this is a larger value, so we have to find the remainder for this. That means procedure is same as before. That is, we have to apply calculator method. We get a value as 2081. You can check the value here. First step, we have to divide this value by 2537. We get some value. We have to subtract that value by the starting values before the point value comes. Next, we get a one value. For that value, we have to multiply 2537. We get a value as 2081. So we get 1819 power 13 is congruent to 2081 under modulo 2537. Call this as equation number 3. Here this value is 2081. So next step, substituting equation 3 in equation 2, we get a value of C1 as C1. Here equation 2 is C1 is congruent to 1819 power 13 under modulo 2537. Here 1819 power 13 is congruent to 2081. So we can conclude that C1 is equal to 2081 under modulo 2537. In the similar way, we have to find C2. So from equation 1, we get a C2 as 1415. Here M2 is 1415. So M2 is 1415 power e value is 13 under modulo 2537. So next we have to do the procedure as before. Here we have to find the remainder value for 1415 power 13. So this is a greater value. So we have to apply calculator method here also. First we have to take, here we know that 1415 square is congruent to some value under modulo 2537. So that we have to find the remainder value first. Here using calculator method we get here 1415 square is 2002225. So next step you have to divide this value by 2537. We get a value as 789.209696. Next we have to subtract this value by the starting values up to the point value. Here we have to subtract this value by 789. We get a value as 0.209696. Next step we have to multiply this value with n value, that is 2537. We get a value as 532. Therefore we can conclude that 532 is a remainder when 1415 square is divided by 2537. Here calculator method is a easy method to find the remainder. So next we are here get 1415 square is congruent to 532 under modulo 2537. But here we have to obtain 1415 power 13. For that, first step we have to raise the power 3 on both the side. We get here 1415 square into 3 is congruent to 532 power 3 under modulo 2537. Here in the left hand side we get 1415, here 2 into 3 is 6 is congruent to, here we have to find the value for 532 cube. So first you have to take 532 cube is given by here 15056876. Next step you have to divide this value by 2537. We get a value as 59349.1399. Here we are doing these values with the help of calculator. Next you have to subtract this value by 0.59349. Next you have to multiply this value by n value, that is 2537. We get a value as 355. Therefore we can conclude that 355 is a remainder when 532 whole cube as 355. That is a value of 1415 power 6. But we have to obtain 1415 power 13. For that we have to raise the power 2 on both the side. We get, here raising the power 2 on both the side, we get 1415 power 6 whole power 2 is congruent to 355 square under modulo 2537. Next in the left hand side we get 1415 power 6 into 2 is 12 is congruent to, here we have to find the value for 355 square. Here 355 square is 126025. Here we have to find the remainder value for this with the help of calculator method. Here first we have to take 355 square. Here 355 square is nothing but 126025. Next step is, here we have to divide this value by 2537, that is n value. We have to divide this value by n value. We get 49.6748128. Next step we have to subtract this value by this value, that is 49. We get a value as 0.6748128. We get a value as this. Next we have to multiply this value by 2537. We get a value as 1712. So we can conclude that 1712 is a remainder when 355 square is divided by 2537. So in the place of this we can write this as 1712. Therefore we can conclude that 1415 power 12 is congruent to 1712 under modulo 2537. But here we have to find the remainder for 1415 power 13. Next step, multiply throughout the equation by 1415. We get here 1415 power 12 into 1415 is congruent to 1712 into 1415 under mod 2537. Here bases are same. If we add the powers we get a value as 1415 power 13, which is congruent to, here if you multiply these two value we get 2422480. Next here we have to find the value or remainder value for this also. We get, here we multiply this value, we get 2422480. Next step we have to divide this value by 2537. We get a value as 954.860071. Next step we have to subtract this value by 954. We get a value as 0.860071. Here next step we have to multiply this value with 2537. We get a value as 2182. So we can conclude that 2182 is a remainder when 1415 power 13 is divided by by 2537. So we can conclude that 1415 power 13 is congruent to 2182 under modulo 2537. Call this as equation number 4. Next step, substituting this equation 4 in equation 2, we get here equation 2 is C2 is equal to 1415 power 13 under modulo 2537. Here this value is 2182. Therefore, we get C2 as 2182 under modulo 2537. Here we get C1, C2 value. Finally, we have to obtain C value. For that, C is equal to C1 into C2. Here we have to substitute C1 and C2 value here. Here C1 is 2081, C2 is 2182. So this is our C value. Here C is nothing but a cipher text. So if we encode this value, we get here, we can take this as here 20812182 as here 20 as one term, 8 as another term, here 1 is separate, 21 is separate, and here 8 is separate and 2 is separate. If we encode this numerical form, we get a value as here 20 is nothing but U, 8 is I, 1 is B, 21 is V, 8 is I and 2 is C. Therefore, the C value is this. Here cipher text is this UIBVIC. Here in this problem, we have encoded the given STOP as UIBVIC. So this completes the problem. We shall move on to another problem. Using RSA algorithm, find the public key and private key with respect to P is equal to 3, Q is equal to 11 and M is equal to 31. Also encrypt and decrypt the number M is equal to 31. Here first take the given data. P is 3, Q is 11 and capital M is 31. Here P and Q are prime numbers and capital M is nothing but a plain text which is given by 31. So here with the help of RSA algorithm, you have to find public key and private key, and also we have to encrypt and decrypt the number capital M is equal to 31. Here we know that first step we have to find N value. For that N is nothing but small p into Q. Here P is 3, Q is 11. If we multiply these two values, we get a value as 33. That's the value of N. N is 33. Next, with the help of N, we have to find phi of N. Here phi of N is given by the formula P minus 1 into Q minus 1. Here P minus 1 is 3 minus 1 is 2. Q minus 1 is 11 minus 1 is 10. If we multiply these two values, we get a value of phi of N as 20. So after obtaining phi of N, next we have to find E value. Here we have to assume that in this step, here we can take E as 7, because 7 we can write this as 1 less than 7 less than 20. Also the GCD of 20 and 7 is 1. So we can take 7 as our E, because E is equal to 7 holds both the condition. Here 1 less than E less than phi of N also satisfies. Also the GCD of 20 and 7 is 1. So we can take E value as 7 here. So after obtaining E value, to find the public key and private key, we also need D value. For that, we know that the congruence is given by, that is D is congruent to e power minus 1 under modulo phi of N, or we can take this as E into D is congruent to 1 under modulo phi of N. Here we know the value of E and phi of N. Substituting the value, we get 7 into D is congruent to 1 under modulo phi of N is 20. Here phi of N value is 20. So we get 7D is congruent to 1 under modulo 20. So by assumption method, we can take here D value as 3. Here if we take D value as 1, 7 is congruent to 1 under modulo 20, does not satisfy. Here if we take D value as 2, 7 into 2 is 14. 14 is congruent to 1 under modulo 20, also is not satisfied. If we substitute D value as 3, we get 7 into 3 is 21. 21 congruent to 1 under modulo 20 satisfies, because 20 divides 21 minus 1 is 20. 20 divides 20 satisfies. So by inspection, D value is 3. Here 7 into 3 is 21. Obviously 21 is congruent to 1 under modulo 20 satisfied. So by the inspection method, we can take D value as 3. Therefore, we obtain E value and D value. Therefore, we can find public key and private key. Here public key is given by the flower bracket E comma N. Here E value is 7, N value is 33. This is our public key. Similarly, private key is D comma N. Here our D is 3 and n is 33. So we get public key and private key value. Here to find public key, private key, we want E value, D value and N value. Next, half part of the problem is complete. Here we have find public key and private key. Also we have to encrypt and decrypt the number capital M is equal to 31. That's the next procedure. Here for the encryption, the formula is given by capital C is equal to capital M power E under modulo N. Here we know that M value is 31, E is 7. So substituting that value we get capital C is equal to 31 power 7 under modulo 33. Here N is 33. Next step, we have to find the value for 31 power 7 under modulo 33. That is the next step. So C is 31 power 7. That's a bigger value. So to have to obtain the remainder value for this, for that first take 31 is congruent to minus 2 under modulo 33. Here we have 33. So to achieve that value, we can take this as here 31 is congruent to minus 2 under modulo 33, because here this implies 33 divides 31 minus of minus 2, that becomes 31 plus 2. 31 plus 2 is 33. Obviously 33 divides 33 satisfies. So first step we have to consider some value that holds the congruency. Here we have to find 31 power 7. For that first step we have to take 31 is congruent to some value under modulo 33. Here 31 is congruent to minus 2 under modulo 33 satisfies. Next step we have to obtain or we have to achieve 31 power 7. For that first step, raising the power 7 on both the side. Here if we raise the power 7 on both the side, we get 31 power 7 in the left side is congruent to minus 2 power 7 under modulo 33. Here 2 power 7 is nothing but 128. Here 2 power 7 is 2 into 2 into up to 7 times. We get 128. That is, here we have odd power, so the negative remains. So 31 power 7 is congruent to minus 128 under modulo 33. Next we have to obtain this value, that is we have to obtain a remainder value when 128 is divided by 33. Next step, here we have to divide 128 by 33. We get a remainder as this. Here 33 into 4 is 132. Here in the place of this we can take a quotient as 3. Here 33 into 3 is 99. If we subtract 128 by 99, we get a larger value. So to reduce that step, we have to take a quotient as 4. Here 33 into 4 is 132, which is close to 128. Also we get a remainder as negative. If we substitute this negative remainder here, negative into negative becomes positive value. So to achieve that procedure, we have to take the quotient value as 4 here. Here 33 into 4 is 132. If we subtract 128 by 132, we get a remainder as minus 4. So we get a remainder value of minus 4 when we divide 128 by 33. That becomes 31 power 7 is congruent to minus of, here 128 remainder is minus 4 under modulo 33. Here we get minus to minus plus value. Therefore we get 31 power 7 is congruent to 4 under modulo 33. Therefore we can conclude that C is congruent to 4 under modulo 33, because C is equal to 31 power 7. Here 31 power 7 is congruent to 4. Hence we get C is congruent to 4 under modulo 33. So we get a CFR text as 4. Therefore, we can conclude that here C is congruent to 4 mod 33, or we can take this as C is equal to, here 4 is nothing but 0, 4. We can take this as, here we know that 0 resembles a alphabet A and 4 resembles a value E. So we get a C, that is CFR text as AE. So with the help of encryption, we get a CFR text as A into E. In the similar way, we have to find decryption. Here decryption is given by the formula M is equal to C power E under modulo N. Substituting C value as 4 here and E value as 3, we get M is equal to 4 cube under modulo 33. So M is congruent to, here 4 cube is 64 under modulo 33. Here we find the remainder for 64, we get a value as 31. Here 33 into 1 is 33, 64 minus 33 is 31. Therefore M is congruent to 31 under modulo 33, or we can take this as M value is 31, or we can take M value as, here 31 we can write this as 3 and 1. So we get 3 as D and 1 value as B. Therefore the decryption value for M is DB. Similarly the encryption value of C is A into E. So this is how we have applied RSA algorithm to find the encryption and decryption value and private key and public key value. This completes the problem. We shall move on to another problem. In RSA algorithm, if P is equal to 7, Q is equal to 11 and E is equal to 13, then what will be the value of D? Write the public key and private key. Here first take the given data. They have given P as 7, Q as 11 and E value is 13. So first you have to take N value as P into Q. Here P is 7 into Q is 11. We get a value as 77. That is the value of N. After finding N, we have to obtain Euler's torsion function, that is phi of N is equal to P minus 1 into Q minus 1. Here P minus 1 is 6 and Q minus 1 is 11 minus 1 is 10. So 6 into 10 is 60. That is our phi of N. After obtaining phi of N, they have already mentioned E value is 13. Here E value is 13 means here we have to observe both the condition holds or not. Here E is 13. Obviously 13 lies in 1 and 60 and the GCD of 60 and 13 is 1. Because 13 is a prime number, the only divisor of 13 is 1 and 13 itself. Therefore the GCD of 60 and 13 is 1 satisfies. So we get E value as 13. Next, they have asked to find the value of D. So to obtain the value of D, we have to consider congruency. D is congruent to e power minus 1 under modulo phi of n, or we can take this as E into D is congruent to 1 mod phi of n. So substitute E value as 13 and phi of n value as 60. We get 13D is congruent to 1 under modulo 60. In previous problem, we can directly, by inspection, we can directly substitute D value. But in this problem, it is complicated to substitute D directly. So next step we can take this as, here we have to find the integer value for D. For that we already discussed in the previous videos, that is for any congruency we have to find the integer value. We have some procedure to find the integer value. Here 13D is congruent to 1 under modulo 60. With the help of congruency definition we can write this as 60 divides 13D minus 1, or we can take this as 13D minus 1. We can take this as 60 into some integer k. So we have to obtain D value. Next steps, take this minus 1 to the right hand side and 13 goes to the denominator. We get D value as 60k plus 1 divided by 13. So in the next step, substitute k value 0, 1, 2, 3 and check whether the value is an integer or not. That is the next procedure. Here D is 60k plus 1 by 13. So check for k is equal to 0, 1, 2, 3 and find the value for D. Here put k is equal to 0. We get D value as, here D is equal to, here 60 into k is 0 plus 1 by 13. Therefore 1 by 13 does not belongs to integer z. Next check for k is equal to 1. Here if we substitute k value as 1 means 60 into k is 60 plus 1 is 61 by 13. Obviously 61 by 13 does not belongs to an integer z. So substitute k value as 2. We get, here k is 2 means 60 into 2 is 120 plus 1 is 121 by 13 does not belongs to integer z. Check for k is equal to 3. Here 60 into 3 is 180. 180 plus 1 is 181 by 13 does not belongs to integer z. Similarly, put k is equal to 4. We get D is equal to, here if you substitute k value as 4 means 60 into 4 is 240 plus 1 is 241 by 13 does not belongs to integer z. So check for k is equal to 5. So we get D is equal to 60 into 5 is 300. 300 plus 1 is 301 by 13 does not belongs to integer z. So check for k is equal to 6. We get D is equal to 60 into 6 is 360. 360 plus 1 is 361 by 13 does not belongs to integer z. So put k is equal to 7. We get D is equal to 60 into 7 is 420 plus 1 divided by 13 is 421 by 13 does not belongs to integer z. Next check for k is equal to 8. We get D is equal to, here 60 into 8 is 480. 480 plus 1 is 481 divided by 13. Here we get 481 by 13 is 37. That 37 is an integer, so belongs to z. So put k is equal to 8. If k is equal to 8, D value is 37. So we get a D value is 37. Therefore D is 37. Hence, after obtaining E and D value, hence the public key is given by E comma N. Here we know that they have already given E value is 30, N is 77. In the similar way, private key is D comma N. Here D is 37. We have obtained D value is 37 and N is 77. So this is about public key and private key. So this is how to find the public key and private key. This completes the problem. Here is another problem. if P is equal to 3, Q is equal to 11 and private key D is equal to 7, find the public key using RSA algorithm and hence encrypt the number 19. So first take the given data. Here they have given P as 3, Q is 11 and private key D is 7. Here D is a private key, so that value is 7. Here we have to find the public key using RSA algorithm. That means you have to find E value and hence encrypt the number 19. Next, to encrypt the number 19, what is the encryption value or number of 19 we have to find. Here they have given P and Q. With the help of P and Q we find N value as P into Q, that is 3 into 11 is 33. In the similar way we have to find Euler's totient function, that is phi of n is pi minus 1 into Q minus 1. Then 3 minus 1 is 2, Q minus 1 is 11 minus 1 is 10. So 2 into 10 is 20. Next we have to find the E value first. So to find E value we must have the condition, that is 1 is less than E less than phi of n and the GCD of phi of n comma E is equal to 1. So they have given D value. With the help of D value we can find E value with the help of a formula, that is D is congruent to E inverse modulo phi of n, or we can take this as E into D is congruent to 1 under modulo phi of n. Substituting D value as 7 we get 7E is congruent to 1 under modulo 20, or this can be taken with the help of congruency form as here definition of congruency says 7E is congruent to 1 mod 20, which implies 20 divides 7E minus 1, or we can take this as 7E minus 1 is equal to 20 into some integer k. Take this minus 1 to the right hand side and 7 goes to the denominator. We get E value as 20k plus 1 divided by 7. Same as previous problem, we have to substitute for k is equal to 0, 1 to 3 and check if it is an integer or not. So put k is equal to 0. If we substitute k as 0, we get E is equal to 20 into 0 is 0 plus 1 is 1 by 7. So obviously 1 by 7 does not belongs to integer z. So next step, put k is equal to 1. We get 20 into 1 is 20. 20 plus 1 is 21. That is E is equal to 21 by 7. 7 1s are 7 3s are satisfies. Therefore E is equal to 3 belongs to integer z. Thus we can conclude that E value is 3. After obtaining E, we can write the public key value as E comma n. Here 3 comma n is 33. So this is about public key. Next also we have to encrypt the number m is equal to 19. Here they have given m as 19. Here 19 is nothing but 1 is B and 9 is J. Here we are writing the numerical number in the alphabetical form as here 1 is B, 9 as J. Here we have to encrypt the message, means you have to use the encryption formula here. Here encryption formula is C is equal to capital M power E under modulo n. Substitute M value, E value and N value. We get C is equal to M is 19, power E is 3 under modulo 33. Here we know that C is equal to 19 cube is 6859. Here we have to obtain a smaller value here. So we can obtain a remainder for 6859. When we divide this value by 33, we get a value as here we can divide 6859 by 33 as here quotient is 207. Here 33 into 207 is 6831, which is close to 6859. So if we subtract these two values, we get a remainder as 28. So in the place of 6859 we can substitute as 28 because 28 is a remainder when 6859 is divided by 33. So we get 6 is congruent to 28 under modulo 33, or we can take this as C value is 28. So we get 2 is C and 8 is I. So we encrypt the message or number 19 as C into I. So this completes the problem. So these are all very easy and important problem on RSA algorithm. This is an application oriented topic in modular arithmetic. Till here we studied every topic on modular arithmetic. From next video we study about linear algebra. If you have any doubt regarding modular arithmetic or any problems to be explained, comment below. Thank you.